I got a call from Oxman, and during the phone call, he was mentioning capsules, things that didn't make sense to me, capsules and microenvironments. And so I asked him, is this a prank call? And he said, no, this is the real thing. If you're by a computer, just go ahead and Google Neri Oxman. So I decided to Google Neri Oxman, and I say, okay, I apologize. Let's see if I can understand better how I can help you out.
Yeah, we learned that the team had very big ideas, and were very open to collaboration. It was clear that they were looking to innovate and to try new things within their industry and in their research.
So when the architects show us the concept drawings, we got really excited because we knew we were going after something really special here. But we knew we would have a lot of challenges in front of us because the concept drawing wasn't practical.
You have to start with the function first. We want the chamber to provide good science. Once that's understood, then there's opportunities to refine and to make things look more aesthetically pleasing.
So the concept, the architect was a glass box, basically. We talked him out of the glass box because of different things. Number one, light contaminations and airflow.
Typically with our designs, we are more for functionality than appearance, and starting to work through this one and having an architect that was very particular on look over functionality threw another wrench into the pile.
Yeah, so we ended up with all solid walls on the environment except for the entryway, and that we did end up doing a full glass wall. We had to do a lot of design work to make sure that the glass would remain condensation-free throughout the operation of an experiment. It was clear from the customer that they wanted a very flexible experiment space. So we had to think through not just one design purpose, but lots of alternative uses for the chambers and design that into the system.
They're wanting to be able to do high temperature studies, low temperature studies, high humidity, low humidity, CO2, possibly even oxygen studies inside of these chambers. So it was a very unique challenge because you're usually shooting for 1 or 2 targets, and with all these variables, it was 12 and a half to shoot at.
The most challenging part of this project was integrating the chambers into the existing space. This was a renovation, so we didn't have a blank sheet of paper to design a room around a chamber. We had to fit the chamber within an existing room. Due to the spatial requirements and the elements that the customer wanted incorporated into the chamber, we had to design some really important systems from the ground up. For example, we had to design our own unit coolers to fit within the very specific spatial requirements.
Because we had to use a unique refrigeration system and a one-off unit cooler, it made us have to make our own airflow studies and plenums that were unique to this system.
The key on temperature uniformity is having the perfect airflow. So we needed to design a plenum that has the right combination of holes, sizes, and density.
I'm particularly proud of the lighting system that we came up with for this chamber. It's an 8-color system, and they're kind of like panels. We then set up the electrical system so that these fixtures could be placed anywhere inside of the chamber, plugged in different spots, put in different orientations.
It was a really flexible lighting system. And the unique thing was that all the wiring was very hidden too, so it makes it look really clean.
We didn't have the opportunity to use our standard process for building the products complete and testing them here at our facility, and more of that fabrication and construction process needed to happen on-site in the lab. And it really required our team to be nimble, to be adaptable, to be open to different ideas and how to achieve the end goal.
We were building an R&D model here in-house while we were finishing the final product out in New York at the same time.
The Oxman project shows that our team is willing to go further in customized solutions, filling the gap where a standard product isn't good enough, and we can collaborate and deploy inventions on the fly with customers to achieve whatever their lab needs are.
I think the reason why we could take on a project like this is because of our passion and our experience.
I love the part of Percival to come to work and get something unique, and somebody has a need and be able to help them out, make that need a reality.
As an engineer, it's very challenging some days, but that's why we love it, is because it's a new challenge day in and day out.
This is one of my favorite projects we've ever done. I'm so proud of the way it turned out, how everybody came together and took an idea on paper and turned it into a really unique piece of laboratory equipment, but also something beautiful.
Being able to look the architect's drawing of what they wanted and being able to see what we did in the field, it was just outstanding. It just kind of like, it made everything worth it.
Oxman is an incredibly forward-looking company, and their ideas are not constrained by limitations of today.
They're so versatile and so flexible, and they have such big ideas. I can't wait to see what research and innovation come out of this lab that change all of our lives, change the world.